Let's look at calculating masses in reactions using the mass to mass ratio. So let's look at example number 1. Given the balanced chemical equation, hydrogen plus oxygen gives us water. If you start with 5 grams of hydrogen gas, how many grams of water can be produced? So the first thing you need to do is ensure your equation is balanced. And as we can see, the equation is balanced there. The next thing you need to do is construct two ratios. Now, one ratio will come from the balanced chemical equation. The other ratio will come from the problem. Now, the ratio will be between which chemical species? It will be between the given quantity, in this case is hydrogen gas, and the wanted quantity, which is water. What is the given quantity? The given quantity is the one you've been given information about, 5 grams of hydrogen gas, and the wanted quantity is the one you have no information about or the one you've been asked about, which is water in this case. So hydrogen to water. What do we do next? Let's find the relative molecular masses of both hydrogen and water. Then we multiply by 2. So hydrogen. On the periodic table, hydrogen has a relative atomic mass of 1. So we're going to get 2 atoms multiplied by 1 to give us 2. Then there's a 2 in front of the hydrogen. So we're going to say 2 multiplied by 2 to give us 4. Then water, 1 by 16. Okay, let me write it here. Water is 2H2O. So 1 by 16 is 16. 2 by 1. 16 is the relative atomic mass of oxygen if you check on the periodic table. The 1 is the relative atomic mass of hydrogen. So 2 by 1 is 2. We're going to get 18. But we have 2 lots of this uh, of water. So we're going to say 18 multiplied by 2 gives us 36. So we're going to have 36. Now, what these numbers mean is that if I have 4 grams of hydrogen, 4 grams of hydrogen will produce 6 grams of water. So these numbers are relative. If I have 4 tons of hydrogen, I will produce 36 tons of water. So the ratio we can get from this balanced chemical equation is that 4 grams of hydrogen will produce 36 grams of water. And this is equals to, now we need also to construct the other ratio from the problem. So we've got 5 grams of hydrogen. 5 grams of hydrogen will produce X grams of water. Don't put a unit on the X. So does it matter which one is on top and which one is at the bottom? It really doesn't matter. What's important is that the masses are in the same relative positions. So what this means is that if I write the mass of hydrogen here, 4 grams, as a numerator on the left side, the mass that I will write as a numerator on the right side should also belong to hydrogen. If I write 36 grams as a denominator here on the left side, so this 36 grams belongs to water. It simply means that the mass that I'll write as a denominator on the right side should also belong to water. So in this way, we'll ensure that the masses are in the same relative positions. So let's solve for this. The grams get cancelled. We cross multiply. 36 multiplied by 5 grams is equals to 4x divided by 4 divided by 4. You divide and you get your x as 45 grams. So 5 grams of hydrogen gas will produce 45 grams of water. Let's look at the next example. Let's look at example number 2. The combustion of propane is described by the following balance equation. Propane plus oxygen gives us carbon dioxide plus water. If you start with 10 grams of propane, how many grams of carbon dioxide will be produced? So we first ensure that our chemical equation is balanced. We can see that it's balanced. The next thing is we need to construct two ratios and set them equal. One ratio will come from the balance equation, the other ratio will come from the problem. Then the ratio will be between the given quantity, in this case is propane, and the wanted quantity, which is carbon dioxide. So propane C3H8 to 3CO2. Okay, so let's find the relative molecular mass of propane and the relative molecular mass of carbon dioxide. So C3H8, 8 atoms of hydrogen multiplied by 1, 3 atoms of carbon multiplied by 12. The 12 is the relative atomic mass of carbon, if you check on the periodic table, and the 1 is the relative atomic mass of hydrogen. So this is 36. When you add them, you're getting 44. 3CO2, 2 multiplied by 16 is 32. 1 multiplied by 12 is 12. So 32 plus 12 gives us 44. Then there are 3 lots of this carbon dioxide, so 3 by 44 gives us 132. So this means that if I have 44 grams requires 130, 44 grams produces 132 grams of carbon dioxide. This is equals to, now we form a ratio coming from the problem. 10 grams of propane produces X grams of carbon dioxide. Now we've set our two ratios equal to each other. The first ratio is coming from the equation here, and the other ratio is coming from the problem. So remember, we discussed this in the earlier example. To say it doesn't matter which one comes on top and which one comes at the bottom. What matters is that uh, if I say the mass of propane should serve as a numerator on the left side, that means that even on the right side, it should serve as a numerator. We can also say, if we wanted, we can also say 132 grams is produced by 44 grams, and this is equals to X grams being produced by 10 grams. So do you see now that the masses of propane are both numerators on the left and the right side? So both of these ratios will give you the same answer. Okay, so let's solve for X. The grams get cancelled. You cross multiply. You have 132 multiplied by 10 grams is equals to 44 multiplied by X divided by 44 divided by 44. X is equals to 30 grams. So if you punch in your calculator, you find that X is equals to 30 grams. Let's look at example number 3, which is the last example. Let's look at example number 3. Consider the synthesis of ammonia from nitrogen and hydrogen gases. Nitrogen plus hydrogen gas gives us ammonia. How many grams of ammonia can be produced from 14 grams of nitrogen gas? We need to ensure that our equation is balanced. Always ensure your equation is balanced. So we can see this equation is balanced. Next, we construct two ratios. Now, the ratios will be set equal. One ratio is coming from the balance equation. The other ratio is coming from the problem. Then, what do? The ratios will be between which chemical species? Between the given quantity, which is nitrogen, and the wanted quantity, the one you've been asked about. So that will be nitrogen to ammonia. Okay. So now let's find the relative molecular masses of each. So nitrogen, if you check on the periodic table, the relative atomic mass of nitrogen is 14. So this will be 2 atoms multiplied by 14 to give you 28. And ammonia, 2NH3, 3 multiplied by 1, 1 multiplied by 14. So this is 3, this is 14, this gives us 17. This is the relative molecular mass, but there's a 2 here, so let's multiply by 2. We get 34. So a mass of 28 grams of nitrogen produces 34 grams of ammonia. So this is the ratio coming from the balance equation. And the ratio coming from the problem will be 14 grams of nitrogen produces X grams of ammonia. So let's solve for X, cancel out the grams, cross multiply. So this will be 34 multiplied by 14 grams is equals to 28 multiplied by X to make X the subject of the formula. X is equals to 17 grams. So 14 grams of nitrogen produces 17 grams of ammonia. So this is how you can calculate masses in reaction using the mass to mass ratios. Thank you for joining me, and I'll see you next time.